Hi all, a very good morning. So I'll quickly log in into my console as well. We'll open up the slides. So in the part of today's class, we are going to start off with application services. We are going to learn about a lot of different services on what is the basic usage of there in the AWS and what can we do along with it. So we are going to start off with the SQS, that is simple queue service. So what is SQS? Now SQS, as the name itself says, it is a simple queue service. So the name queue that comes in between is something that helps us to know that it is a kind of queue where the messages can be stored temporarily. So Amazon SQS is a web service that gives you access to the message queue that can be used to store messages while waiting for the computer to process them. Amazon SQS is a distributed queue system that enables web services applications to quickly and reliably queue messages that one component in the application generates to be consumed by another component. Now, if you go back and look back at what to understand SQS much better, right? So the second part of the definition that says it's a web service which enables the applications to quickly and reliably queue messages that one component of the application generates to be consumed by another component, which means there is one application here which generates some messages, and these messages are basically sent to the queue so that there is some other application which can actually consume and process it. Right? So one of the application generates the messages which are put up into the queue, and the second application actually goes back to the queue, picks up the messages and starts consuming them. So that's why we call that a queue is basically a temporary repository for the messages that are awaiting to be processed. Now, using the Amazon SQS, what can we actually do? We can actually decouple the components of the application so that they can run independently. Now, in this case, if I want this application which has actually got dependency on this one which is going to generate the messages, right? So in this case, it can be something like web application which is a front end for the users, and this could be a database application which is a backend. Now, if I want to remove my database application, the dependency on the web application, I can put across a queue in between so that even though the people are trying to order something on my e-commerce website, it is not going to affect even if the database is going to be down, right? Because whatever orders they are going to place, they are going to be put across into the queue, and whenever the database application is up and running, it's going to pick up the messages from the queue and start writing the transactions, and then only you will be getting a confirmation email saying that yes, your order has been processed, right? Or your order has been confirmed. So while we are trying to place the order, it may sometimes say that your order is under process, and you will get a confirmation email within a minute or two. That is because usually they have something like SQS queue in between, which has got all the messages the moment I'm going to place the order. But in a little while, all these messages get processed and are written down to the database, and then I'll get a confirmation message saying that yes, the order has been processed and has been confirmed. So with the help of SQS, we are actually able to decouple the complete components itself. So any component of a distributed application can store in a fail-safe queue Messages can contain up to 256 KB of text in any format. Now, the size of a specific message which is going to be sent across in the SQS is basically around 256 KB. And any component can later retrieve the messages programmatically using the SQS API. So we basically use the API in order to get the messages from this queue so that the database application will be able to consume them and process it and remove it off. The queue basically acts as a buffer between the component producing and saving the data and the component receiving the data for processing. So this is basically like a buffer in between the components that are generating the messages and the component that is basically consuming the messages. This means the queue resolves the issues that arises if the producer is producing work faster than the consumer can process it, or if the producer and consumer are intermittently connected to the network. Now, when this is going to act as a buffer, we get a couple of advantages. One is, even though the web application can generate millions of requests at one point in time, the database application doesn't matter even if it is not able to consume all of them. They are going to be stored here, right? So it can consume at a later point of time. So even though the web application generates higher number of messages, I will be able to process each and every one of them with the smallest period of the time. When the database application is all okay, it is going to pick up the message, each one of them one after the other, and is going to process it up. And even though the web application goes down, the messages will be still available in the queue, that the database application is going to pick it up and then process it and then store it across. So that's what here we say, that even the producer is producing more work faster, it doesn't matter, consumer will be able to process it because messages are basically stored in the buffer in between. And even if the producer or consumer are intermittently connected, which means even if any one of them goes down, it doesn't matter, but we will be able to put the message in the queue very safely. Now let's try to understand one of the example using the SQS here. So this is an example of SQS. What is being done in this case is a user is trying to upload the image from the one second. So in this case, we have a user who is trying to use his computer or laptop or a mobile device in order to upload the images. Let's understand that this is a kind of Instagram application where the people usually go ahead and apply the images. Now, if you see, this is the end product that I want to have. On each and every image that gets uploaded on my website, I'm going to just give it as a copyright, saying that this is at a copyright at some XXX company, something as such, right? So this is the product that I want at the end, the moment the user gets uploaded the image. So what's happening in this case? Whenever the user is trying to upload the image, it is basically going down to the S3 bucket. And in the moment it goes to the S3 bucket, you remember we have something called as events. In the events, we can actually trigger 3 of them, that is SQS, SNS, or a Lambda function. Now I'm going to trigger a SQS function here. So the SQS function is basically trying to create a message, like what it has to do. So it has to pick up this image, whichever is going to get uploaded. The moment the image gets uploaded, it is being sent as a message which says that pick up the initial just loaded image, send it up to the Lambda function to process it. And this Lambda function, what is going to do? It is basically going to pick up the image, and it is going to put across this watermark that is copyrighted XXX, and then it is going to store back the image into the S3 bucket here, right? So this is what happens overall in the backend. So using the SQS here, I'm trying to create a message. So in the message, I'm trying to say that pick up the original image, second step will be put a watermark, and then the third step will be put it back to the S3 bucket. So that is a kind of message that we would like to create in the SQS. So that message is basically sent to the Lambda function, and now message can be in the Java or Java or Node.js or the C# or the Python. So you can write in any of the 4 languages in the Lambda function. So I'll write up that specific part of message here and send it to the Lambda, and the Lambda is going to process the complete query for me here. So in terms of the example that we just learned, asynchronously pulls the task messages from the queue, right? So the moment image is going to get uploaded to the S3 bucket, it is being picked up by the SQS and it is put into the queue. Retrieves the named file. So the moment this is there are some certain number of steps that I'm going to write, right? So in this case, our SQS has already got a message which has got certain number of steps. So the first step will be like retrieve the specific file, process the conversion, write the image back to the S3. The moment these three tasks are done, what I'm going to do, I'll say task has been complete, and that particular message will be put back to the queue, right? So and deletes the original task message, so that I also come to know from the SQS itself, yes, this task has been completed successfully, and the original task message which was available, that also gets deleted in this case. And now my processor is going to look for the more messages if there are any, right? So this is going to basically pick up the message from the queue. Let's say I have got here like 1, 2, 3, 4, 5, 6, right? Let's say each of them is a single message. 1 is a message, 2 is a message, 3 is a message. Now whenever let's say message number 6 is picked up, so the message number 6 is basically processed, and then once it is processed, it is going to put down in a, here we have two different types of queues. One is the response queue and the request queue. So we are going to learn about both of them in a little while. So what happens is, once the request is processed, it is put back into the queue here saying that yes, this message has been processed, and the original message from the first part of the queue is being deleted, right? So I come to know that yes, this is a part of the list which has been processed, and this is a part of the list which has to be still processed yet. So basically there are two different types of queues overall. One of them is a standard queue and the second is a FIFO queues. So the standard queue is basically the default one which we use all across, and FIFO, as we all know, is basically first in first out queue, we call it. Now Amazon SQS offers a standard queue as a default queue type. The FIFO queues were recently introduced around 4 months back, which was in September or October last year. Before that, we just had only the standard queues. The standard queue doesn't follow any specific order of the messages. So if I'm trying to send messages like this 1, 2, 5, 3, 4, something like that, so it is not necessarily that the message number 1 is going to get processed first. It can be a message 5 which gets processed first, and then the message 2, and then maybe the message 3, 4, and then maybe the 1, right? So there is no specific order in which the messages get processed in the default queue. But there are certain advantages, like the standard queue can let you have nearly unlimited number of transactions per second. So there's no limit on the number of transactions when in case of standard queue. You can have up to unlimited. And standard queues guarantee that a message is delivered at least once. So whatever message is going to come into this queue, it is going to ensure that this message is going to be delivered to the for processing at least once. However, occasionally more than one copy of messages might be delivered out of order. So there could be a chance that one message can be delivered a couple of times, but that is very rare. I'll help you to know what is the situation where the same message gets delivered a couple of times in the very next couple of slides. The standard queue provides the best effort ordering, which ensures that the messages are generally delivered in the same order as they are sent. It tries to see that they are put across in the same order, but it doesn't guarantee about it. So there may be a chance that the message number 5 gets processed first and then the others. So that was about the standard queue. And next we have the FIFO queue. FIFO queue is basically, as we just learned, first in, first out. Now FIFO queue complements the standard queue. The most important features of this queue are first in, first out delivery and exactly once processing. So this will ensure that the message is processed only once, as well it is delivered in a specific order in which they are sent across to the queue. The order in which the messages are sent and received is strictly preserved, and the message is delivered once and remains available until a consumer processes and deletes it. So until this message is not processed, it is not going to move on to the second message at all, because we are trying to send it in the FIFO queue only when I have a certain number of dependencies. Let's say the message number 5 can be processed only after the 4 is complete. 4 can be processed only after the 3 is complete. 3 can be processed only after the 2, and same is with the first one. So in this case, until the message 1 doesn't get processed, we have to wait in the queue for the second message to get the processing done. So this strictly follows the order and will ensure that the first message is processed successfully and is being deleted from the queue, and only then the second message will be sent across to the processing part. Duplicates are not introduced into the queue, so that is advantage here. FIFO queues also support message groups that allow multiple ordered messages within a single queue. So we also can send across a message groups. So we can send the messages in the groups. So you can say that I want to club up 1, 2, 3 as one part of the message, and then these 3 doesn't have any dependency on the 4, 5, 6, which is the second part of the group. So you can actually club across certain set of messages and say that it is a message group. But there's a limitation here, that is it can handle only 300 transactions per second. But when we talk about the other one, that is standard queue, it has nearly unlimited number of transactions, but here we have 300 transactions. But we get certain advantages here, that is the order is strictly maintained, the message is delivered only once. There the order is not maintained, messages may be delivered couple of times, right? So there are certain advantages as well as disadvantages in both the cases here. Now let's understand in a little more deeper way on how the SQS actually works across. Now this is the component 1, which is trying to produce a message A and is trying to send it to the SQS queue. So the moment component 1 produces a message, it is being sent across to the queue and it is being stored like this, right? So each message will have a name. So here I'm trying to name it to the message A. Now there is something called as visibility timeout clock. So what is this visibility timeout clock? So each message will have this visibility timeout clock already mentioned onto it. So moment the message is produced, this component will be tagged to each of these messages. Now when the component 2, which is a consumer, is going to pick up the message from the queue, right? So it is going to go to the queue and say that I want to process this message. It will pick it up, and then the moment the message is being picked up, the visibility timeout clock starts. So what is the visibility timeout clock? Visibility timeout clock is the amount of time in which the message has to be processed up. So let's say I have written certain number of steps inside this message, which I know that can be completed within the 40 seconds of the span of time. So I'm going to give the visibility timeout clock as a 40 seconds in this case. So the moment my component 2 is going to pick up the message from the queue, it is going to start the visibility timeout clock. So within next 40 seconds, I have to complete the processing of this message. Now, what happens if the processing doesn't complete, and what happens if the processing gets completed? Right? So if the processing gets completed, that's well and fine, which means the component 2 was able to complete the message processing within the stipulated time, and then it deletes the message from the queue that it has been processed successfully, and it will place a acknowledgement request saying that yes, this message has been processed. But what happens if it doesn't complete in that specific stipulated time? Then the same message goes back and sits into the queue again. So the SQS is again going to make an attempt to delivery for this message back to the consumer, because it was not processed at the first level, so it is going to be given for processing again. That is where the duplicates can get introduced, because the first time the message was processed until half the way, and then again the second time the same message might be sent across. So this is something like this, the request queue and the response queue will have. So the request queue will actually get all the messages, and once the message is being processed successfully, I'll delete the message on the request queue and put across the message in the response queue saying that this message with the number so and so has been processed. Right, so this is how it basically works. We have request queue and the response queue, where the requests actually come into the request queue, and moment the consumer is going to pick up the message in the request queue, it gets processed. It is going to say the acknowledgement in the response queue saying that the message has been processed successfully, and we are going to go ahead and delete the original message from the request queue. Now let's understand how auto scaling actually works in the real time in the background. So if you see, the number of users are going to hit across onto my web server, right? So we are actually tracking the CPU utilization of the main server on how many users have been using it, so that we can scale it accordingly up or down. So let's say the number of users are going to increase in this section. So what happens in this case? It is going to send across the request queue saying that the number of users have been increased. Or let's say if I have kept an alarm at the CPU utilization being hit at a 70% or more, it should create an alarm. So what does that alarm do? Basically, it is also going to send it across the request queue saying that as per the user's request, it has to go ahead and scale the EC2 instance. Remember, what do we do in the auto scaling? We create scaling activities. In the scaling activity, first we create the metric, which is called a metric, which is going to be CPU utilization, with the help of which we are going to create an alarm. What do we do? Whenever that alarm is going to trigger, we are going to say that please put up one EC2 instance to this group. So that's what is happening. So those are the steps, right? So I'm going to track the CPU utilization. If it's at 70%, then I'm saying that first send a notification. Second, go ahead and add a new EC2 instance as well. Right? The same happens here. That part of message is being placed inside this. Once the request is being picked up by the SQS queue, who is going to be processing this message, like the processing servers are always there behind the scene. So these servers are going to pick up the message and then they read out all the instructions. So immediately it's going to send an email notification, and then immediately it's also going to spin up a new server, so that the new server is added back here and the users will be able to get the seamless connection onto their web server. So in the response queue, I get a message saying that the message has been successfully processed, and then it gets deleted from the main request queue. So SQS and auto scaling really works hand in hand a lot, so that we do not face any difficulties. And actually SQS was the very first component that Amazon introduced when they launched the cloud. So SQS is still very much popular among the exam topics, as well as sometimes in the interview they do ask about what is SQS in general, because it has been one of the most basic topics that was introduced very earlier during the time the Amazon has launched its cloud. Now let's learn about some important parts here. So 12 hours visibility timeout clock. So as we all just learned about visibility timeout, right? So what is the maximum amount of the visibility timeout that I can actually set across for the message? That is 12 hours is the maximum that we can actually set out the visibility timeout in this case. And Amazon SQS is engineered to provide at least once delivery of each messages, right? So whatever message is being sent to the queue, remember it will be sent across at least once to the consumer for processing it. But we just learned how can it get delivered multiple times. It is only because if the visibility timeout clock expires, the message couldn't be processed, and so that it get back to the SQS queue and sits there. So again the message is being sent for the processing. That is where the duplicacy can actually happen. So whenever we are going to design a system, we should design it in such a way that it doesn't create any errors or inconsistencies, even if the message is being picked up for the second time and it's being processed across. So usually the messages are of the size 256 KB, right? So that is a maximum size we can have a message of about, and billing is usually done at a 64 KB chunks. So if you have got a message of 256 KB, it will be divided into four chunks of 64 KB for billing purposes. And you can also put across 10 messages with a maximum total payload of 256 KB, which means, as I said, one single message can be of size 256 KB. So you can actually put across 10 different instructions which can be of total size of 256 KB in a single message as well. Each 64 KB chunk of payload is billed as one request. So for example, a single API call with 256 KB payload will be billed as 4 different requests. So we just learned about what is default visibility timeout clock. So The moment I'm going to spin up any SQS queue, the visibility timeout by default will be 30 seconds. However, the maximum I can set out across is 12 hours. So what is visibility timeout clock? It is basically the time that starts when the consumer starts picking up the message from the queue and starts processing it. So it is a stipulated amount of time within which the message can be successfully processed. So if you think I'm going to send out a Java code in the SQS queue, and I think that it is going to take 1 minute to process it, then I'm going to keep the visibility timeout as maybe, let's say, 2 minutes as such, for a buffer time as well, so that maximum within 2 minutes this message can get processed successfully. One second, guys. I'll be back in just 2 minutes. Sorry guys, just keeping you waited. Okay, so we just were learning about the visibility timeout clock. So default visibility timeout is 30 seconds and maximum that we can set across is 12 hours. Now, if you want to change the visibility time in between, you can actually use this API, which is called as change message visibility, which can set across the new time value, right? So in case if you think the current time value is 2 minutes and then you want to change it across to 5 minutes, something as such, so you can use this change message visibility, which is the API to be used in order to specify the new timeout value. And remember, it's the timeout value will start only the moment consumer is going to pick up the message and is about to start the processing. So you need to remember this name of the API, that is change message visibility. So sometimes it does is appears up in the exam point of view. And next we have something called as long polling. So it's really important to understand what is a long polling, because even this question in the exam appears a lot. So what is a long polling? Now, if you see this example here, there is a component that is actually generating the messages, and there is a component that is also consuming a messages from the queue. So what consumer basically does is it is always keeping an eye on the queue, that if there is any message, please give me that message so that I can process it across, right? So the application who is called as consumer here is continuously trying to check the messages in the queue if there is any for processing. Now sometimes there may be a case where there are no messages. Let's take an example of e-commerce website at midnight 2 o'clock. Now there will be very few persons who might be ordering it, right? So maybe in the daytime there are around 15-20 messages that get up piled up in the queue, which this consumer has to process. But during the night time there would be hardly 1 or 2 people who would be ordering it, and that may get immediately processed, right? Because the messages in the queue are just little and the consumer is very much ready to pick them up and process it. So what happens in the long polling is this consumer is always keeping a check on the queue if there is any message or not. So now if consumer has to always keep a check, so what happens in this case? Consumer is trying to spend its CPU cycles, right? It is also again a server behind the server behind. So it's trying to consume the CPU cycles and it's trying to go ahead and check every time in the queue if there is a message for processing, if there is a message for processing or not, right? So every time it's always hitting, maybe at every 1 second, or maybe at every 2 seconds, or maybe at every 3 seconds. So in this way, I'm trying to consume a lot of CPU cycles for this consumer. So how do we actually save them across? So there is something called as long polling. Long polling, this consumer is going to hit to the message queue to check out if there is any message for processing or not. If there is no message, then the consumer is going to wait for 20 seconds. That is the maximum long polling time I can have. So it's going to wait for 20 seconds overall to see if the message has arrived. So in case, let's say the message arrives at the 15th second, so it will pick up that message for processing. It will go back to the consumer, process it up, and then comes back to check for a new message. Right. So the moment I'm going to now again come back to the queue, as I have set the polling time as maximum as 20 seconds. So it's again going to wait for 20 seconds. So instead of hitting every back to back every 2 seconds to see if there is a message or not, which is going to consume a lot of CPU cycles, I'm going to set across the long polling time as 20 seconds, so that whenever the consumer is going to come to the queue to check out if there is message or not, it has to wait for 20 seconds. And if the messages doesn't come within 20 seconds, then it times out. But until then, it will wait for the message to see if there is any, right? So if it comes at the 10th second or 12th second, then I'm saying at least 5 CPU cycles. Let's say it is actually checking at every 2 seconds, which means in 20 seconds I'll be able to lose out to approximately 10 CPU cycles in this case, right? So if I have to protect all those 10 of them, maybe I'll just put across the long polling. So if I'm getting the message at 11th second, I am saving 5 CPU cycles in this case. right? So there's just a rough example. So with the help of long polling, we are basically trying to save the CPU cycles. So SQS long polling is a way to retrieve the messages from your SQS queue, while the traditional SQS queue has a short polling, right? By the normal traditional SQS queue, the moment you're going to set up, it will have a short polling. So even if the queue is being polled empty, which means if the queue is empty as well, my consumer always keeps checking if there is any message or not in the queue. So the SQS long polling doesn't return a response until a message arrives in the queue or a long poll times out. And the SQS long queue in the polling makes it easy and inexpensive to retrieve the messages from the SQS queue as they are available. So the maximum long poll timeout is here being is 20 seconds that can be set across. So the SQS finding out is the last part which we are going to learn when we cover up the SNS, which is the next part of our topic, which we are going to learn in the tomorrow's session here. So any questions or queries in the SQS part from any one of you here? Yeah, I'm just going to show that up. How do we go into the SQS queue and play around with it? It's not complete practical, but at least a few parameters that we are going to show how we put across. There we go. I'll click on the services here, and then I'll just type in SQS here so that we'll get it easily. So there it is. It is a part of some messaging services mostly. So there it is. So it does give me some examples here on what all we'll be able to achieve with this QSQ. So we can actually ensure that it is all highly available, and it can scale my business, and it can also reduce the complete cost. So how does it reduce the cost? It is because now let's say instead of having a database server of a very heavy capacity to consume all the transactions from the front end side, what I can do is basically put across the SQS queue in between, right? So all the messages. Now the good example here would be online voting system. Let's say you're trying to watch a show which is going online at this point of time, and they are actually expecting you to vote here. So, and they want to show the results maybe in a little while or maybe live as well. Sometimes it can be both the cases. So if it is to be a little while and the performance is currently going on and they expect you to vote, so let's say they see a surge of number of users to from, let's say last week it was 1,000 users who were just voting it. Now this time the show got very much popular and there are 1 lakh people who are voting it, but I have not designed my system very well. So what can I do? I can actually put across a simple queue service in between. So I can have a database of maybe just M1 large system and even the main web server, which is also of M1 large itself, right? I'm not taking very big servers. I'm just trying to manage the very small servers, but I have a SQS queue in between so that I am not going to lose any vote that is going to come from the front end, right? So all the messages which are going to hit my front end is going to be converted into message and is being stored into the SQS queue. And I'm trying to reduce the cost because I'm not going to use a bigger size of database which is going to consume these messages. So I'm going to have a very small size itself, but I'm putting everything into the SQS queue so that it will be able to send across to the consumer, and the consumer is going to finally process it up. So we'll click on the get started here. So the moment we go ahead, it is going to ask me a couple of things. So the first thing is the name of the queue here. What is the name that you would like to give across? So you may say that I would like to give in across as test queue. Earlier it used to ask about the different type FIFO or standard queue. I'm not sure again if they have removed it. Let me check across. I guess they have removed it again, the FIFO and the standard queue. They have made it only as one because it was just recently introduced, as I said, the FIFO queues. They were not earlier. It was only that we used to get. Okay, let's see. So this is very simple to set it up. I just need to give the name as a test queue. And then the first thing I'm going to go set out is default visibility timeout. So what will be the default visibility timeout? So whenever you're going to create queue, it is by default 30. You may change it up to maximum of 12 hours as it says here. There is a maximum number of hours you can put it as the visibility timeout. And retention period. So the moment one message comes into the SQS queue, for how long will it be available in the SQS queue? So the maximum is 14 days. You can store any message in the SQS queue for maximum 14 days. If within 14 days it is not being processed, then it's automatically getting deleted. So by default, the retention period is being set to 4 days by Amazon. So you can go and set it between 1 minute to 14 days anywhere. And then the maximum message size, as we'll know, all know, it is only 256 KB. Then we have delivery delay. So what does this delivery delay do? So the amount of time to delay the first delivery of all messages added to this queue. Now the moment the message is going to come to the queue, let's say it has to be actually immediately picked up by the consumer, but I want to delay the delivery of this. So yes, I'll be able to do it, but maximum is the 15 minutes is what I can deliver the delay by, not more than that. So 0 seconds is minimum, 15 minutes is the maximum that I can go for the delivery delay. Then we have receive message wait time. This is nothing but the maximum amount of time that long polling receives call will wait for a message, right? We just learned about the long polling, right? So the name that we use here to configure the parameter is receive message wait time. So by default it is 0, which means every 1 second is going to check out if there is any message or not. So the consumer is going to hit my SQS queue very badly every 1 second, which is going to consume the CPU cycles of my consumer. So if I have to save them, I can go ahead and make this as maybe 10 seconds or maybe 20 is the maximum that I can actually have. And if you want to use the redrive policies, you can just go ahead and click them, and then we get the dead letter queue. The dead letter queue is nothing but, let's say the message, I have got a message like 1 2 3 4 5 6. The message number 6, let's say it was initially picked up by the consumer to process it. It was unable to process it within the stipulated time. Then it is sent back to the queue again here. All right, so it will be sent back to the queue, and again the message number 6 will be attempted for the delivery so that the consumer can process it. But let's say even if after the second attempt also it was unable to process it, then what happens is it will be falling into the dead letter queue, right? So the dead letter queue is basically a place where those kind of messages will be put across which couldn't be processed even after multiple deliveries, so that we'll be able to come to know, okay, this was a message which was not processed. Maybe there is some error that is coming, right? So maybe I have not written the Java function correctly and there is some error while it is getting processed. That can happen because we are humans. When we write a specific code, there is a chance that it may fail, or there may be something new that has come into picture because of which that has failed, or the database where it is trying to put the transaction, maybe the database itself has got corrupted and it's not working well, right? Anything can happen. So if you want to track out those kind of errors, issues, what are happening, so if the message is being sent across multiple times and it doesn't get processed, it goes and stores into the dead letter queue, which means this message is now dead and cannot be processed anymore. So I'll pick up that message, see the error, why it is not happening, and then I'll be able, again will be able to repair and then resend the message. So this is how we can basically go and create a queue, and then just click on the create queue here, and it's going to create it, right? So this queue can be basically used across with a lot of applications. As I just said, web application and the database applications can be completely decoupled using the specific SQS queue. Let's check out what all is available in the SQS queue actions here. So you can send a message just to check out from your side immediately. Configure a queue, add permission, purge queue, delete queue, and then subscribe queue. Yeah, SQS fanning out we are going to learn. That is what is called as subscribe queue to the SNS topics. So in the configure queue, let's see what are the parameters. Okay. So I guess they have again removed out that FIFO and the this part. So maybe they were just trying to foresee by helping the users to check out if these things are working out as a part of standard and the FIFO queue. So maybe they have just removed it. As I just said, I'm not able to see that portion here. So any questions or queries from any one of you before we close the session for the day? Divya, Rahul, Shiva? How about you, Rahul and Shiva? No, we don't discuss about that tool. I'm not sure. I'm hearing it for the very first time. AMS scripting tool. No. The example, as I just gave you, is the simple one. Here, this is the URL from which I'll be able to retrieve the messages. So this is a URL from which the message could be retrieved by the consumer. So think about the kind of online voting application where the people are actually sending the messages to so they are trying to cast a vote. So my web server, which is a front end, is the place where the people are trying to put across the vote, or maybe it is a mobile number from where the messages are coming or people are voting, and that will be directly sent across to the queue, and the consumer is going to use this URL in order to hit it and get across the messages. Okay, then, so we close the session here for the day. So we were able to cover up the first part of application services, that is SQS. Of course, SQS itself is a little longer topic in all of these services here. Rest of the topics are a little smaller. We will be able to cover up at least a couple or more of them in next part. So in the next part, we are going to look out at what is SNS and what is HWF, and then we are going to cover up the other portions of our application services in this case. So thanks all for the time here. Have a great day, and we'll meet back again tomorrow at the same time to continue the next part of our AWS session.